Hello and welcome back to Higher Maths Functions and Graphs. In this lesson we're looking at using our domain, range and composite function knowledge and applying that to our knowledge of logarithmic and exponential functions. So state the range of the following functions: f of x equals 4 to the power x minus 7. So I'm going to have a look at doing this graphically. The range is the possible y values. So I'm going to consider the graph f of x equals 4 to the power x. So I know that's an exponential function because the x is the power, the index. So that graph would look like this. It would also go through 1, 4 and 2, 16. Okay, it does not hit the x-axis. So at the moment, the possible ranges, the possible values for y are greater than to 0. Can't be equal to 0 because it never actually touches the x-axis. We're basically looking at any positive value. But we also have this minus 7. So that is going to drop this curve down by 7. It's going to move the whole curve down by 7. So it'll be crossing at -6. And as it never reached the x-axis, this graph doesn't touch the x-axis. When I move it down by 7, it will never get to a height of y equals -7. It'll get very, very close to it, but it will never actually touch it. So the range would be any value greater than -7. So f of x is an element of the real numbers, so f of x can be any number as long as f of x is greater than -7. Part B, f of x equals 3 to the power x plus 1 plus 3. So this here, treat this as f of x plus 1, so that will move the whole curve 1 to the left. So that's not going to affect the range because it's moving it left or right. It's not moving up or down any. So the range will not change. The y coordinates will not change. Plus 3, so that will move the whole curve up by 3. Okay, so I'm just going to look at y equals 3 to the x. And I can think about that moving 1 to the left if I need to. But again, it's not going to change the y coordinates. It's only going to change the x coordinates. And then there's plus 3. So again, y equals 3 to the x does not touch the x-axis. So at the moment, the y coordinates are greater than 0. They're all positive. So if I move that up by 3, move this whole thing up by 3, so it's up here, then the y coordinates will always be greater than 3. Because every single point on that curve is moving up by 3. So my range would be f of x as an element of R, where f of x is greater than 3. Again, the whole curve's moved up by 3, so the y values will always be 3 or more. Question 2, state the domain of the following functions. Remember guys, the domain is the value that x can take. So I've got g of x equals log to the base 3 of x minus 4. So I'm just going to consider g of x equals log to the base 3 of x. And then I'm going to think about moving the whole curve 4 to the right. So I'm not even going to try and sketch this. I'm just going to sketch log to the base 3 of x. So remember our log curve looks like this. It would also go through 3, 1 because the base is 3. So at the moment, the values of x here can be any positive value of x. So it could be 0.01, it could be 1, it could be 4, it could be 19. It would never be 0 because this curve does not touch the y-axis. It would never be a negative value either for x. So at the moment, x is greater than 0. If I move the whole curve along by 4, all of these values here will move along to here. Okay, so if I move it all along by 4, rather than x being greater than 0, x would have to be greater than 4. So x is an element of R where x is greater than 4. Right, I will do part B, part 2b, and also question 3 in a separate video.